Okay, here's the second half of 5.4, Theorem 512. Perpendicular segment from a point, B, to a line, AC, is the shortest segment from the point to the line. So this perpendicular segment is always the shortest distance to this line. Obviously, it's shorter than this distance BA and shorter than this distance BC, but it'll always be the shortest distance. But it's not enough to just believe that, right? We have to prove that. That's what we do in geometry. So let's do the proof. Given BX is perpendicular to AC, and BC is any non-perpendicular segment from B to AC. So here's some non-perpendicular segments. So this represents all other segments that are not perpendicular. So that's why we're going to use that. So we'd start off by saying that which is given, which is BX is perpendicular to AC, and that is given. And then let's just number these angles here. 1, 2, 3. We could say that angle 1 and angle 2 are right angles. And we just know that because that is the definition of perpendicular. And therefore the angle 1 is congruent to angle 2 because all right angles are congruent. And that means, and this is something we haven't done a lot of, but that means that the measurement of angle 1 is equal to the measurement of angle 2. And we can switch to equality. We can go from congruence to equality because that is simply the definition of congruence. Alright, now, here's where it gets fun. Angle 3 up here is an interior angle to this triangle BCX. And angle 1 is an exterior angle. And we learned a couple lessons ago that angle 1 has to be greater than angle 3. Now let's say I was to call this angle 4, right there. Well, we learned a long time ago that angle 3 plus 4 should add up to equal angle 1, regardless of what kind of triangle it is. The two remote interior angles will equal angle 1. Well, if I was to get rid of angle 4, and I just had 3, well that means that 3 has to be less than angle 1. And so I can write that. I can say that angle 3 is less than angle 1. And let's see, that was the corollary to the triangle exterior angle theorem. That theorem is probably totally butchered, but that's what that word is there, theorem. Alright, well if angle 3 is greater than angle, or less than angle 1, and angle 1 is equal to angle 2, we can make the next statement, which is that angle 3 is also less than angle 2. Alright, now this is where we start to use new stuff. Since angle 2 is opposite this segment BC, and angle 3 is opposite this segment BX, if 3 is less than 2, then the side opposite 3, BX, has to be less than the side opposite of 2, BC. So we could say safely that BX is less than BC, which is the same thing that we have here. I mean, we could switch it around and just say BC is greater than BX. Oh, I forgot to fill in some information here. Our step in number 6 is just simply substitution property of equality. That's all we did there. Just substituted in 2 for 1. And this last one doesn't really have a name. So in the book it's just named 5.9 and 5.10. So I thought I'd give it a name. So I'm going to give it the name. I called it the triangle side to angle inequality theorem. There you go, triangle side angle inequality theorem. Now that's just a made-up name, but in my class, if that's what you use, we'll let it slide because otherwise it doesn't really have a name. And that theorem is just the one that basically says, hey, if you have some angles in a triangle, and one angle is bigger than another angle, then the side opposite that angle is bigger than the side opposite the smaller angle. That's all it says. And if you wanted to, if you didn't remember the theorem, you could just basically write out in words everything that I just said. But you don't really need to. You can just the triangle side angle inequality theorem if you'd rather. I'm not really picky. You do any one of those that works for you. Alright, lastly, summary. If a perpendicular line is always the shortest distance from a point to a line, what would be the shortest distance from a point to a plane? I said talk it over with your neighbor and explain your response, but think about that. See if you can figure it out. It's a good little thought question. Try and picture that in your head. Okay, and that's it for this video.